Oh my god, people. Like, really? The Canton Triangle? Like, be real. Everybody knows it's witchcraft. Speaking of which, pardon the pun, we all know what the real witches, the Catholic Church did to hide their corruption. They just transferred their offenders to another county. It's a kill two birds with one stone approach. You can both hide the offender and export your special style of corruption to another county. That's how it started with just a few churches that were corrupt, to being multiple countries of churches that were all corrupt. And right now, I believe, our Cardinal Pell became an Italian resident who was in fact found guilty by a Victoria State County Court jury, and then our High Court did the right thing and overturned his convictions and shipped him off to Italy, where he probably enjoyed a few more children before he died last year. But I do digress. We were talking about Flat Earth, that's right, where scientists have put considerable effort towards debunking their own sciences and convinced us mere mortals that Australia doesn't exist and that we are all just CIA paid actors with a fancy accent, whilst also forgetting that some of us are scientists ourselves. Which brings me to the Zorro equation. I saw some of you sitting there scratching your heads going, what the hell is she on about? And maybe that's because you didn't see my 2 Zorro videos. Zorro is the formula that Trooper Dunning-Kruger decided best fitted his accident reconstruction of John O'Keefe being run over by an SUV. That's right, Zorro. Turns out he wasn't saying Zorro.
How would you calculate that?
In pedestrian collisions, I use a Zorro formula, Zorro throw formula.
A what formula?
Zorro.
What does that mean?
It's a type of formula.
I know what you're thinking. It sounds like Zorro, but it's not. I don't know if it's the Boston accent or what it is, but what he's actually saying is Searle formula. Searle's method is used in forensic road accident investigation to determine the vehicle speed from the thrown distance of the body. Sounds appropriate, right? It's probably the most commonly used equation within the UK, and it's derived by a chap named John Searle in 1983. And it's only designed to give a general calculation, not an absolute speed value. So let's break it down. Let's say we have object 1, the vehicle, and object 2, the pedestrian. So looking at the equation, you can see 1 and 2 very clearly. V stands for velocity. So we would have the velocity 1 of the vehicle, velocity 2 of the pedestrian, and M stands for mass. So M1 is the mass of the vehicle, and M2 is the mass of the pedestrian. It's pretty simple, really, but I don't expect you guys to do any of the math. Trooper Dunning-Kruger, however, does give us some of his values, which I will plug in, and we'll see how close he was, or wasn't, as the case may be, to calculating the approximate thrown distance, according to the speed that he chose. Let's start by solving the left side of the multiplication symbol. V1, according to Trooper Paul, was 24 miles per hour. I have converted this to metric, and that equates to 10.73 metres per second. The Commonwealth theory also supposes John was standing still, so 0 metres per second is stationary. So 10.73 minus 0 equals 10.73. That's the left side solved. Let's move to the right side using the values that we were given. The mass of the vehicle that Trooper Paul gave us was grossly overestimated. It was not curb weight, it was capacity weight. So the difference is the car being completely empty, sitting at the curb, or the car being completely loaded up, interior filled with boxes and shit, and all the seats filled with people. It would weigh 7,300 pounds-ish. So with that caveat, we will use the weight that he gave us, which is 3,311 kilos. And then the pedestrian's weight was around 170 pounds, which is 77 kilograms. So let's go ahead and plug those values into the equation. M1 was 3,311 kilos, and M2 was 77 kilos. We solve addition first, so 3311 plus 77 equals 3388. And then we solve what's left in the brackets. 3311 divided by 3388 gives us 0.977, which we rounded down to 3 decimal places for the purpose of the exercise. And finally, multiplying 10.73 by 0.977 gives us a value of 10.48. Therefore, the throw is approximately 10.48 metres. However, throw distance and displacement are two different quantities. The throw distance represents the total length of the path travelled by the pedestrian's body after the impact, which would be short and intense motion. Displacement represents the total distance between the pedestrian's initial and final positions. So we need a different formula. It's called the lateral displacement formula, or sideways throw formula, as Trooper Dunning-Kruger called it. The lateral displacement formula looks like this. Since we've already worked out the vehicle's speed and the mass of the pedestrian and the vehicle, we can just plug those straight in. Trooper Dunning-Kruger's theory is that the impact was perpendicular, so that's 90 degrees. And his approximated duration of impact was half a second. Solving what's in the brackets first, sine times 90 degrees is 1, and 77 kilograms divided by 3311 kilograms gives us 0.0233. Again, solving the brackets on the left gives us 5.365, and solving the brackets on the right gives us 1.0233, and then the left divided by the right gives us 5.24 metres. So what we can see by doing these calculations is that Trooper Dunning-Kruger's theory is based on centre mass impact. This would give approximately 30 feet throw distance and approximately 20 feet lateral displacement. But then he had to explain the lack of injuries to the rest of the body that a centre mass collision would cause. This would involve a whole other calculation, which I will spare you, which would involve calculating the reduction of displacement resulting from only the arm being struck and taking into account the effective mass and moment of the arm, as well as some of the absorption of the impact resulting from the pirouette, which would also reduce the linear displacement. But no, Trooper Dunning-Kruger left it at these calculations that we just did because they fit the scenario, not the other way around, which incidentally would have helped him to identify that the speed of 24 miles per hour that he chose between specific key cycles was actually incorrect.
Crash investigators use these laws of physics to work out what happened by working backward. They can use the distance travelled by the pedestrian on impact to calculate the impact speed between car and pedestrian. From there, they can work backwards to calculate the speed the car was travelling at prior to braking.
By working backwards, you'd come up with a different speed. However, nobody knew where John's body landed. Nobody marked it. Nobody measured it. Nobody photographed it in relation to landmarks that could have assisted in giving measurements. You may recall Trooper Dunning-Kruger stating there was no other formula that he could use. He essentially said every other formula would have underestimated the values, meaning he wouldn't be able to match the 20 metres lateral displacement or the 30 metres throw distance that he was given and had to match. Sir Arthur Conan Doyle said it best when he wrote, "It is a capital mistake to theorise before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts.